Welcome back, everyone. So, sir, can we start? Satish, sir?
Sure.
Yes, sir. So now the session 2 will start of this FDP program. So by Dr. S.V. Satish, Professor and Head of the Department, Mechanical Engineering Department, PS University, Bangalore. So his title of the topic is Industry 4.0 for Smart Factories. So I'll just give a brief introduction about this, sir. So sir has a professional experience of total 29 years of teaching and research experience at PS University, Bangalore. So some of the achievements of the sir is he was the Institution of Engineers, in that he was awarded the best paper for friction stir welding of aluminum sponge by non-porous edge retention. So presented at the prize distribution ceremony of 36th Indian Engineering Congress held at Vigyan Bhavan during 2021. He was the Vice Chairman for Indian Welding Society, Bangalore chapter during 2011. He has attended and presented projects in manufacturing and automotive domains at various international conferences, forums held in countries such as USA, Singapore, Sri Lanka, Canada, South Korea, China, and also in India. Sir has served as the PESIT integrator for PACE program, General Motors Initiative, which constitutes 53 colleges across the globe during 2006 to 2014. Sir is also a PSIT lead for ICICI Trinity program, also the team mentor for Aero Design Team, ALIOS, which has won high recognitions and awards for building unmanned aircraft vehicle for SAE competitions held in USA and IIScs and IITs. Sir is currently working on hybrid and electric car design for sustainable urban transportation with futuristic sensors and drive mechanisms. He has also authored measurement and metrology subject content for Edurite Technologies, e-content developers. So some of the funded projects carried out by Sir was he was the principal investigator for investigation on participants kindly mute. He was the principal investigator for investigation on solid state weldability of fast tempered.
No, we are not looking like that only. Okay, just say I want to see that how.
He was the principal investigator for investigation on solid state weldability of fast tempered ductile iron by friction and friction stir welding for potential applications in armored vehicles and trucks from 2006 to 2008. So it was funded by Naval Research Board. He also established partners for advancement in engineering of collaborative engineering education, a lab at PS University funded by General Motors and HP, contributing to more than 2 crore rupees worth of hardware and software during 2006 to 2014. So some of the undergraduate projects undertaken by under Sir's mentorship includes, he was the principal mentor for Hybrid Formula Race Car Event 2016, designed and manufactured for Imperial Society of Innovative Engineers Race Car Event. The team secured second prize in the acceleration event. Also, he was the principal mentor for AIDRA, design and manufacture of an electric car in 2012 to 13, funded by PS Institute of Technology, Bangalore. On the same topic, paper was presented at the forum presentation PACE Forum 2013 in California, USA. So Sir was principal mentor for Samkaran, hybrid vehicle design manufacturer from 2010 to 11, funded by Army Base Workshop, Cyrus Control Private Limited and PS Institute of Technology. So also published one international paper and one best paper award at PACE Forum 2011, Korea. Also won the Best Innovation Award at Auto Show in 2011, Palace Grounds in Bangalore. So he was also the principal mentor and project lead for PACE Sustainable Urban Transport Vehicle Design in 2010 to 12, won 5 awards for the project report evaluation and best paper presentation out of 47 participating international universities. So this event held at PACE Forum 2011 in Canada and PACE Forum 2012 General Motors, Shanghai, China. So under Sir's, the papers published in journals, it is 7. He have presented papers in the international conferences, it is 12. And in the national conferences, it is 5. So the 3 guest lectures delivered by the sir on the automotive sensor technology and technology options in green manufacturing, and also introduction to MEMS. These were the 3 guest lectures delivered by the sir. So he has a manufacturing experience of production manager, coordinated and lead the manufacturing team to fabricate and furnish 1000-bed PS Medical College and Hospital located at Kuppam, Andhra Pradesh during 1998 to 2004. Established production unit at PS University, Bangalore. So conducted skill-based occasional training program for school dropouts and placed more than 600 candidates in various manufacturing industries. So we welcome you, sir, for this session on Industry 4.0 for smart factories. So the session is to you, sir. Thank you.
Thank you, madam, and good morning, everyone. Can everyone see this slide? Can you just confirm? Can you see the slide, please?
Yes, sir.
Yes.
So I first of all thank the organizers for giving me this opportunity to do a small presentation on Industry 4.0 smart factories. So let us try understand. Morning, even I had attended Sunita ma'am's presentation by Ultron Industries. She did a very good job trying to make us understand that what is Industry 4.0. So for some time, I'll also touch the introductory part of what is Industry 4.0 and where we are. And then let us discuss about smart factories requirement. So in my presentation, basically, since I am from mechanical, so I'll be leaning too much towards the manufacturing. And not only that, some of the important highlights of electronics and computer science, how it will be integrated also, we will discuss. So the slide presentations will consist of a lot of text because it's a faculty development program, and I believe in that as faculty, we need to reach the students the other side after this training program, wherein we need to give them the benefit of understanding and to take up the course also. See, finally, we need to emerge out this as a course in almost all the branches, because this is what is industry from now onwards. So let us go with what exactly is Industry 4.0 introduction. So it is Industry 4.0 means fourth industrial revolution. With the first 3 are mechanization, electricity, and information technology. That is how the first 3 were been highlighted. Anyhow, I'll touch these things once again in the future of my presentation. So next is Industry 4.0. When we are talking about, it's a combination of Internet of Things and Internet of Services. These two things all of us need to keep in mind. So 2 things that makes already Industry 3.0 is when we are talking about manufacturing segment, so it is pretty advanced. And Industry 4.0, we are integrating too much of Internet of Things and Internet of Services. How and why we'll discuss. Okay. Next is Industry 4.0 is worked out by German manufacturing. So though it was been thought about in USA, but otherwise where exactly it has been given prominence and where the technology development has been taking place is too much in it is seen too much in German. Otherwise, followed by European Union, China, India, and other Asian countries. Why these countries? Why these countries? Let us understand that, because these are all the manufacturing hubs. So India also tops the automotive industry. I don't know how many of you know that. We are the leading manufacturers of trucks. So we stand number one in manufacturing of trucks. India leads all other countries. So otherwise also we stand within the fifth slot. So we are a huge manufacturing hub, and we are catering the global needs, and that is how I'll start with this. Next. So what is this vision of Industrial 4.0? It is the future industrial business will build global networks to connect their machinery, factories, and warehousing facilities as cyber physical systems. So what is cyber physical systems? I'll touch that later part of this, how it will be implemented. But otherwise, what is that we are doing under Industrial 4.0 is that we are connecting machinery, factories, and the warehouses, which will connect and control each other intelligently by sharing information that triggers actions. Now, cyber physical systems will take the shape of smart factories, smart machines, smart storage facilities, and smart supply chains. And these are all big businesses. In the global world today, we are seeing that there are these students from Karnataka, mainly wherein all engineering colleges are getting into artificial intelligence and machine learning, data analytics, and then computing. When we are talking about all this, everybody are being consumed into this segment of manufacturing, which is evolving very fast, and under the name cyber physical system, which is taking shape as smart factories, smart machines, smart storage facilities, and smart supply chains. And what happens here? What exactly is happening here is that it's very simple. The operations technology, what we will call it as in manufacturing under mechanical, the operation technology is merged with information technology, that is the IT, under Industrial 4.0. This is what is happening. So let us define this. So it stands for, Industry 4.0 stands for Fourth Industrial Revolution. The framework for Industry 4.0 depends like the digitization and integration of horizontal vertical chains, value chains, we call it as the digitization of products and services, the introduction of innovative business models. This I'll touch and explain how it will happen. So why Industrial 4.0? Here, let us ask a lot of questions for ourselves. So that is how always I believe, like, to teach students and we learning. So first is that why this Industry 4.0? The rapid increase in data volumes and cloud storage, computing power, and ubiquitous network connectivity has enabled analysis of operational data that was earlier impossible. A product development requires analysis for quality performance, also for business operation analysis is required. I'll give you examples for this. So I'll just rush through why it is required, and then we'll discuss one by one. Then the introduction of new form of human and machine interactions using augmented reality. So this, all of you keep in mind. See, Industry 4.0, all the presentations, including what Samantha was trying to explain, was that till when we were talking about Industry 3.0, it was only making machines wherein that they interact with themselves and working. But the personal touch, the human touch was lacking in Industry 3.0. But otherwise, it will be reintroduced along with the machine interactions. Even the human interactions will be put in augmented reality systems. So that is what she told, that a system of manufacturing semiconductors, wherein that she showed a pad, like, wherein that people from remotely understanding and controlling a manufacturing activity. So otherwise, it is the augmented reality. Here, human touch was missing in 3.0, which will be re-established in 4.0. It is the innovations in easing the transfer of digital data to something physically usable. That is advanced robotics with AI and 3D printing technology, as well as rapid prototyping. So what are the characteristics of this 4.0? So first thing is that the vertical integration of smart production systems. What is this? There is a need for networking of smart factories, smart products, and other smart production. It uses cyber physical production systems, which allows the manufacturing plants to react quickly for variables such as demand levels, machine defects, and unforeseen delays. So, what is that? In any manufacturing firm, see, it was always planned in a manufacturing firm for either mass production, batch production, or there are exclusive, like no tailor-made industries wherein that they take one-on-one order and they will try to furnish. That is small scale production. But these industries of mass production, batch production, once established, when there is a change of process, so ma'am was mentioning that change of cell phones from one version to the other version, how much flexible we are, how much money it goes in making this change for integrating something new is something challenging. Is it that we need to invest is a bigger challenge today, and how do we adapt changes is what we will be foreseeing and without any delays. The challenge is that because when the customer needs it, there's not much time. Like she mentioned earlier, car production means 5 years of drawing to production. That means prototyping, analysis, all this used to take a lot of time. But today it is just that as on today it is 18 months. As on today it is 18 months. Anything that the new product goes in, coming out from scratch to product into the market with sales and services is around 18 months today, but they want to bring it down. How much I'll be highlighting at the end of my presentation. Also networking and integration involving smart logistics and marketing services. So here, what is this? Cyber physical production systems, a brief picture I have put. So there is a factory environment, there are missions, and there is a user interface. Here, directly, this is being using virtual private networks like your computers and phones. It has been integrated with the factory automation, that is supply chain, enterprise resource planning, product design, production plan. And in all these processes, human in loop decisions is also a part of it. So how it is different between 3.0 and what is 4.0 we'll discuss, but otherwise this is what happens, that human is a part and parcel of the manufacturing system. So if you see here, somewhere remotely you are sitting with the computer or pad, and then your factory automation is completely been visualized, and any changes etc can be easily made. How the changes are made, why the changes are made? Because say example, say if we take Bangalore airport, okay, so they are coming with the second terminal now, they are opening the second terminal immediately, like the infrastructure has to be enhanced. So when you are enhancing the infrastructure, you give a private party somebody to run the taxi business, say, so you are given the order for 3 companies, so at once they are placing the order of 500 or 1000 cars from a manufacturing company. So now they don't have much time, because the real-time infrastructure has to be created from the scratch. So how fast you can arrange all the material that is required, all the parts that are required, and how fast. So this data management and manufacturing is a bigger challenge, and they don't want to have the whole idea here of Industry 4.0 is that they want to come out of inventory. They don't want any inventory. They don't want to have stored raw material or semi-finished product which is ready for assembly. All these things they want to minimize. So the entire supply chain will go on a change. Enterprise resource planning will go on change. Product design will be pretty faster. Any changes need to be incorporated pretty fast. Then engaging all this, mainly the manufacturing should happen. The production plan has to be executed so that in minimum time we come out meeting the customer demands. So this is where CPPS comes into picture. So this is how a semiconductor industry looks like, what she was mentioning. So this comes under MEMS. So it's the next future is like how small the integration system that we can build into this automation systems, wherein that the micro electromechanical systems will serve serve with giving proper output in terms of efficiency and quality. So the second characteristics is horizontal integration through global value chain networks. Integration will facilitate the establishment and maintenance of global networks that create and add value. Here, through engineering across the entire value chain, it's all about complete life cycle of product is traced from production to retirement. So this comes under one of the very important thing, how the product life cycle is been planned. So the product life cycle is something like this. Say earlier, if I buy the car, any car, the product life cycle used to be 20 years, but it was not monitored. The health monitoring was not happening. Today, if you're talking about your cell phones or your automotive, from the day the parts are being manufactured, it has been coded and it has been kept in the data library. So all the products which has gone in assembling most of you are using your car. So all the parts in that car, the manufacturer has coded and kept, and which batch of part has entered into your car, they know that. So when you go to the service, so if you are talking about a clutch mechanism or a brake mechanism, I'm just taking one example, a clutch mechanism in that batch, in the last, if the car is used for 5 years, how many of them failed? How many of them is performing well? The health condition is already known, because every time you take, if it's not replaced, what has been replaced only gets updated. Otherwise, the other health is already monitored. It's all already monitored. But in future, it's a different, in Industry 4.0, it is altogether different. So online also it will be monitoring. How it will be done? Let us take examples. And next is acceleration of manufacturing, the concept of value chain. This is what the characteristics of Industry 4.0, that how do you create the value chain for the every activity that goes in. So how is this happening? How is this Industry 4.0 happening? It's happening through drivers and enablers. The first one is drivers. Here, when we are talking about drivers, the first level is technology upgradation and digitalization. Here, low-cost hardware intelligent machines and influx of data can be attributed to the advancement of Industry 4.0. The rise in data volumes has led to the coinage of the term big data. So what is big data? You need to explain. This has caused a greater need for ever for companies to store and gather information, and doing so make better use of it. Second is the network and connectivity. Without network and connectivity, it is impossible to make industrial IoT. IIoT is what it's named as. So it's very important here. Fast internet and increased use of technologies such as remote data access, RDA, and radio frequency identification, that is RFID, to collect and distribute information supports the concept of Internet of Things as a potential global digital infrastructure. So I'll just give you an example here. So FASTag has been introduced now in Nice Road also. Most of you would have used Nice Road. Otherwise also, FASTag is a requirement today. So any vehicle manufacturer, along when he is selling, it's mandatory that he will sell a RFID tag to the vehicle, vehicle itself, so that transaction, the business transaction, toll payment, etc. Right now it's only toll payment, but otherwise they are thinking other things also. It is connected. So it is how it works through the internet only. I'm just giving you an example. Okay. So remotely in some villages, if you are passing, maybe you are going to Tirupati or you're going to some Pune or something, so many places you will pay the toll, and it is all interconnected. Even in remote places it's connected, but there should be a strong internet. But this has made the globe look it has shrunk the globe. Okay, so everybody are connected. That is how we are able to attempt this Industry 4.0. Next is competitive edge as the driver. The combination of customers' human input and dynamic data analysis and response may mean that future a digital ecosystem will be created whereby human decision is augmented through algorithms, which will increase the accuracy in production and reduce the time and cost of manpower. So all put together, these drivers, this is how it looks. So there's a smart factory here. what all the things? So first thing is that the IoT, next comes 3D printing, augmented, wearables. Already all of us are available about wearables, but otherwise it keeps a constant update by using wearables, advanced robotics, artificial intelligence, big data, and cloud computing. So all these put together is the technology drivers. So this is an exclusive topic wherein that people are investing a lot of money on all these technologies, and this has evolved in a big way. And take it from me, next 1 to 1.5 decade, so people will be consumed extensively, especially engineers, and almost all of them are needed. It is just that most of the institutions and all, we see that lack of people who are joining mechanical, but they need to be told that even in computer science and electronics, they need to introduce some of the subjects. The reason is that because it all revolves around factories and manufacturing and businesses only. And unless you know where we are using, example I'll give you here, one more example I'll just give you here, where exactly the smart factory is taking us. So smart factory earlier, complete manufacturing of the car means assembly, especially talking about assembly. They used to have big plants and they used to do it. Say example, Mahindra and Tata have few at Hosur and few in Pune, Maharashtra. But otherwise, today's requirement is that they want to establish the assemblies at places where there is huge demand of products. And like no, getting a lot of products and manufactured and keeping in the rack is not the requirement today. It is just in time when it is required. Say example, so if you are booking a car today, for that even the raw material is not procured. It will be procured later, and that is where is the smart business is leading us. So they don't want to have inventory. They don't want to have inventory because you don't know what all changes it comes, because every the next day there's a new technology that has been developed and the new thing that has to be integrated. So how fast you can integrate and how fast you can, so it has to be pretty flexible here. And by 3D printing and other techniques, it has become, say example in future how it will work in future. Not a few places it's taking in defense and all, this technology has already been used in some countries. But otherwise, I'll just figure out one example. Say example, there will be a day when you take your car for service, something has spoiled, some important component has failed. So they'll just the person who is servicing your vehicle, he will just put a requisite, and nearby plant of theirs, it will just print that part and they'll send, and within a short time you'll get back your vehicle. And that part was not existing unless it was failed in your vehicle. That is the reason it was being created, and it will be integrated. That is the future. That is the future wherein that we are taking this industry 4.0. So let us understand what all the key enablers here for making this industry 4.0 and success. First is the business. An increase in efficiency is considered as the main driver for the companies to implement the IoT in their process, followed by predictions for cost saving. So cost savings is huge here. It's almost closely 50%, and it's almost making double the margin after you sell the product. So that is where the companies are being getting advantage, which would result from its implementation. 45% of the respondents state the decision making is optimized when using the data gathered and analyzed, while 43% support that the flexibility of the process is increased. Second is leadership. See here, there are new posts which are being created in the industry today. Okay, so 40% do not have the role of chief IoT officer in their organization, which they should have. So today, only around 50% of the companies, they have the chief IoT officer, but otherwise they need to create one. Reason is that they need to explore where all we can put this Internet of Things and take the concerns of how the system is been efficiently working and how is that we can make it more profitable. Next, application, 63% in the production process to support the real-time process control, 47% to gather data and make informed decisions on predictive maintenance, and 43% to monitor and control missions. So what is that here we are discussing is that So something fails is previously, before only can I predict that. So there are various MEMS devices, wherein that it give the alert on of machinery. Say example, a thermal component, and somewhere temperature is increasing beyond what it has to be. Otherwise, should not go. So if it can sense and it can take an artificial intelligence decision and correct then and there, see that how it can be cooled. If that tool, if it's not integrated, it should give it becomes a monitoring system. It just tells that, okay, something is going wrong, and should I shut it down or so by variables, wherever you are, you can take the decision that, okay, you want to shut it down. So it may be a thermal, like no load bearing capacity has increased, or thermal thing increased, or there may be a failure of component. All these things, if we can have the data, okay, online data, that is, it should pitch in the online data, then only these things is possible. So here the key enablers, so where all it can be used, this much, this is the best way of to understand. So production process control, 60% is required. Predictive maintenance, around 47%. Monitoring and control of machines, 43%. Support the energy savings. See, I don't know how many of you know that. Today, almost all the manufacturing industries run on computer numerical control machines and robots, AGVs, automated guided vehicles, ASRS, automated storage and retrieval systems. So these things are already been on UPS. The way your computer labs are there on uninterrupted power supply, very similar to that. There cannot be power fluctuations because a lot of electronics, very expensive technology has gone into them, so there cannot be power fluctuations. And for doing this, energy systems play a major role, and they have optimized for with a minimal power consumption. They will perform with very high efficiency, tool selection, etc., for material removal operations. Then the supporting operational efficiency, tracking goods, materials inside the company and along the supply chain, that is within the factory and outside the factory, for delivery or warehouse purpose. So even that has been tracked. Health and safety of thing. IoT for gathering data to sell third party, others for 12%. So these are all the key enablers that are there. But all the key challenges in front of all the engineers is that lack of unified leadership that makes cross-unit coordination difficult within the company. These are all the things which the industries are facing as on today. Data ownership concerns when choosing third-party vendors or for hosting and operations. So this ma'am also told, and two of you asked the question how safe the data is. Then I'll take examples and explain all that. Lack of courage to launch the radical digitalization plan, lack of in-house talent to support the development, the deployment of Industry 4.0 initiatives. These are the places where people need to be trained and fitted in, so that there are people there, they are not understanding that they are needed. Okay, already a lot of people feel in the industry that they don't have the jobs, but otherwise they need to be trained by the organizations like us, wherein that they need to be told how this IT can be related to the OT, information technology, with the operation technology. Then difficulties with integrating data from various sources to enable initial connectivity, lack of knowledge about technologies, vendors, and IT outsourcing partners that could help execute the core initiative. Well, there's no one fit in all approach. So here we need to explore and see to that how this can be. Majorly we need to think about return on investment using digital solutions. So the benefits include improving optimize equipment effectiveness and maintenance, reduce costs in real-time production and monitoring, predictive maintenance, more automation, 3D printing, and quality control, which is the top, like Industry 3.0 standards, and which was very stringent on this. Quality has always become a total quality management, and it has been addressed in Japanese format. And today, almost all industries try to have Six Sigma segment under their belt, and they have established that. Now it is only that how do you integrate IoT into that and innovate faster. So here, use of 3D printing, remote export, and collaboration technologies has made it very easy for this. So benefits include increased efficiency and productivity. So if you see here, I can see estimates that switching to automated production 4.0 can boost productivity in technical professions by 45 to 50%. IoT assisted production has already been deployed by companies like Airbus, SCO, Siemens, and a number of other leaders in the industry 4.0. Human robot teams are also emerging on the factory floor. So here MIT estimates that collaboration with robots can reduce workers' idle time by 85%. These are all the challenges and already solutions have been framed. So Australia's Drake Trailers, a company who recently added a welding robot to its production line, reported 60% increase in productivity among their staff. So one of the Cornell company of one of the largest power capacitor manufacturer in North America managed to double their speed of labeling process from 125 parts of an hour to 250 parts an hour by employing a robot to work alongside with a human team. So these are the benefits of technology and investment. Next is mission downtime reductions. The major thing is here. Okay, so in any investments, like no, how is that we can reduce the mission downtime reduction? So your predictive maintenance in Industry 4.0 means that equipment failure will be identified before it occurs. This is where people need to fit in. All the engineers need to track. So what is that? It is required. We need to choose proper sensors and develop appropriate algorithms wherein that it will take the monitoring well before the system fails, and it generates either a signal telling that monitoring, just informing the person that okay, something is going wrong, or it will take a corrective action by using artificial intelligence then and there. So next is machine learning powered systems can spot repetitive patterns that precede failures, notify your teams and have them schedule an inspection. Deloitte that predictive maintenance can reduce the maintenance planning by 20 to 50%. It's a huge time. Okay, the maintenance planning, if you reduce it, is that. So when you are invested in CNC machine today for production capacity, a turning machine will cost not less than 3.5 crore, and return on investment generally will be 2 to 3 years. So now if there is in 365 days, even 3 days of failure, there is a lot of money that has been, they want to predict earlier and see to that online maintenance happens. So this is how these technologies are used. Here, diminish total maintenance cost by 5 to 10%, increase equipment uptime and availability by 10%. Then maintenance repairs and operations. Next is already in action. Companies also. So here GE Aviation improved MRO efficiency by nearly 10%. So what is this MRO? Maintenance, repair, and operations. So that itself has proved a big boon for the companies by integration of Internet of Things. Next is improved supply demand matching. So cloud-based inventory management solutions enable better interaction with suppliers by pairing your inventory management system with a big data analytics solution. And generally it forecasts at least 85%. And real-time supply chain optimization and gain more visibility, like no possible bottlenecks and your growth is the beneficial. So what are the companies that have been benefited already by Industry 4.0 are these companies already which are in talk, wherein that they're some units where they have introduced Industry 4.0 or the study material for most of the engineering, and even you people can just take the information for how to understand this implementation. So you may be an electronic engineer, mechanical engineer, or computer science engineer, but otherwise you can always check the data analytics, how they are doing, or where the data they are generating through the sensors, and what is the actuators they are using, how they are controlling the systems remotely. So these things have huge Next is benefits in business. It increased competitiveness of business, increased productivity, increased revenue. Then comes employment opportunities. Then a lot of people this is the thing. So as on today, you're seeing that almost every other person who has been trained have been observed today with high package for IT resource management under this industry 4.0 segment. Next, the majorly it is used for optimization of manufacturing processes, development of exponential technologies, and better customer service. Oh, some of the industrial revolutions that we need to understand. Already I told I'll discuss value chain. What is this value chain? So horizontal value chain is supports information technology, sales, and marketing, whereas the vertical values chain supports the production. So the actual production in the industry, that is the tool, mission, and all the other work handling equipment like robots and AGVs and SRS, how it has been utilized, and which has been integrated with sales, support, and maintenance thing. So where are we and what is that ma'am has explained? So I'll not get into too much of this, but otherwise, what is industry 4.0? Only I'll highlight the fourth industrial revolution is a transition to digital transformation of the manufacturing industry, merging of the physical and digital worlds, the rapid increase in data volumes, cloud storage, rental computing power, and network connectivity has enabled analysis of. The first thing is that these things are being created. Okay, your cloud data management and your integration through networking and internet, all these are today it's made. And say example, the way we went from offline classes to the online classes and remotely reaching the candidates. So today this workshop has been conducted remotely, so everybody are attending. Very similar to that, industry is also evolving. I'll just get into that. And some of the other important things includes 3D printing simplified. So where we were and what has happened, I'll just tried all that ma'am tried explaining in the first part of our presentation. I've just put into one small picture so that you people can understand and build on this. Okay, first it was dinosaur enterprise, wherein that the product variety was very high, it was skill based. And then come the Null enterprise, wherein that batch production started. Then came winning horse, wherein that mass production came into the thing. And today it is lizard enterprise. So it is becoming agile. That means what is ordered only you create. It is required only you create. Unnecessarily don't create and keep. And that is what it is, because globally the population is increasing, because things are becoming very expensive, production costs are becoming expensive, labor cost has become expensive. So here why this lizard chameleon kind of thing, wherein that say according to the market demand you change your business and you change your manufacturing technology. So that is where we are entering today. So this is a graph. This picture is a graph. It's variety versus the response. So what was the needed in the actual environment, and are you able to put? So when it was industry 3.0, mass production used to happen, and product variety was almost minimum. But today with Lizard Enterprise, they want to get back and they want to change this. They want to make more customized kind of product. So what is need, what is the capacity, for that you manufacture. And for doing this, industry 4.3.0 has come very handy, because already it was been run successfully. Today it is just that including IoT and sensors and actuators and making the data analytics, you can enter into this Lizard Enterprise. I'll just play a small video for all of you, because I'm just going on talking about manufacturing, but I don't know how many of you real time experience the industry, how it looks. So I'll just play this video just to show operation. So that was a video I just wanted to show you because see, manufacturing is something there in industry 3.0 was more of programming. Your robot is being programmed, your machine is being programmed, your conveyor system is being programmed, your work handling, part selection, everything, including stacking of raw material for assembly, components, etc. Everything was automated, and with like no storing and retrieval was also being programmed. Now, what is that they're looking is much beyond that. So, what is the current, say, how a program system works is that there's no intelligence in it. It is just that you are programmed accordingly, it will follow the structured way of working. But industry 4.0 is more of decision making. Here there will be a human also will be interfaced with a gadget. All that it is sensing. See, every activity that was taking place in that work environment can be visualized in your system, in your computer or in your smartphone. You can visualize. That is what is required. Right now, like no, only business part, how many tools are there, only the inventory part used to be tracked, but they want to track something has gone wrong, why it has gone wrong. They want to predict it, they want to stop it, because any failure there, the entire line stops. So one attached to the other. And ma'am was telling that I had worked with General Motor. I'll just give you a brief. When I visited South Korea for one of their sedan class manufacturing automation segment, every 3 minutes, like no, one car will come out with the line. So in the video you saw that like no, after some time the one vehicle will move to the next. Then there's a time interval there. Okay, there's a time interval. So at same speed the vehicle manufacturing happens. Like no, that time interval of one vehicle taking one slot to the next slot, how much time it will move. So in assembly also, then what we saw in a welding robots and welding line, but otherwise assembly lines are also lines like this, wherein that and we keep manufacturing. So every 3 minutes the one vehicle. Say example, if you take TVS, the two-wheelers what they manufacture, one of the two-wheelers in Osu Road, what I see, every 5 minutes one scooter will come out. So they have two lines. So every 5 minutes the two vehicles will come out in the line. So that is the speed of manufacturing. Okay, so nothing can go wrong. Say some batch of maybe a clutch or steering mechanism has gone wrong. So you have heard that some of the phones are not let in some like no aeroplanes. Reason is that some battery problem is there. There is not that all the batteries have a problem. One batch may have a problem. So generally, like no, we call back in the mechanical industry, we'll call back how it is done. We are monitoring when the vehicle goes to service, and when the complaints from the customer telling that this failed, something has failed repeatedly in a particular batch, few things are failing, then that is reported. Okay, because we need to do the replacement. The part number is entered automatically, the part number entered, vehicle which vehicle the number is entered, the vehicle like no, which batch of product had entered in making the steering. So all, if there are a particular percentage, if it exceeds all in that batch, whatever the it was been fixed for the vehicle's steering or clutch plate or something, we'll call back and we replace it. So that is where this Internet of Things come in very handy, wherein that predict that and stop it instead of failing off. Like no, after being put into use, can I predict and take control today, now only. So that is where a lot of intelligence need to be created. So why is big data the core of industry 4.0? So the industry 4.0 is the fusion of real world with the virtual world. So this is what it is. So how it is done, I'll just brief you with a schematic. This digital revolution is marked the technology that makes advantage of big data and artificial intelligence to nurture automatic learning systems. Then manufacturers in today's marketplace seek to achieve business intelligence through compilation, analysis, and sharing of data across all key functional domains in order to achieve production excellence. So how did this lead to fourth industrial revolution? The interconnection between systems and computer and the ability to analyze large amounts of data have made possible the existence of intelligent machines that can make informed decisions without any human involvement. Here, Internet of Things has been connecting elements for many years, but the value extracted from the data through big data has taken the term to a new level, the Internet of Systems. I'll just give you a glimpse here. What is that it is? So, see, one of the student from computer science from our university, so who was working in one of the IT company, recently met me for an like no, he wants to go abroad for IELTS studies. He met me. So then I asked him what is that he was working later in the company. He told in Internet of Things. So IoT only. So then I asked him what is that the work assigned to him and what is that they were doing. So he was talking in Germany, a coffee vending mission for coffee vending machines, what flavor of coffee moves faster and what is the brand and so they have an internet of things that runs beyond, okay, anywhere, any different like no franchisee, wherever it has been delivered. So what is the flavor and like seasonally, month wise, climate wise, all that they were just taking the data. That means they were collecting the data at every moment, every time, every part of the month, and they were just keeping this data. First thing is collect the data. What is that raw data? You collect a lot of data you collect. Later on, when you put it in a appropriate way, which I'll just explain you in my future slide, how it comes handy. So then you put it in an organized way. So that is where like no, you can find solutions under fourth industrial revolution. So cases of usage of big data in factories improvise these many things. First is improving warehouse processes. So here, thanks to all your electronic technologies for sensors and portable devices, companies can improve operational efficiency by detecting human errors, performing quality controls, and showing optimal production or assembly rules. Then elimination of bottlenecks. So big data identifies variables that can affect performance at no extra cost, guiding manufacturers in identifying the problem. Next is predictive demand. Here, more accurate and meaningful predictions thanks to the visualization of activity through internal analysis, that is the customer preferences, and external analysis, trends and external events beyond historical data. This allows the company to modify, optimize its product portfolio. So I'll just give you an example. What exactly is predictive demand evaluation? Say example, today most of us we will visit. Say example, you have something in your mind that you want to buy. So it may be a screen for your house, so windows. So you are just Googling and Amazon or Flipkart and other suppliers also direct, like so there may be a company like if I take an Indian company, Bombay Dyeing or something who are manufacturing. So you go to their sites and you Google. So all these are recorded. So the third party who are doing the big data analytics, they just capture this data. How many of them at this point of time are having like a particular item searched? So based on that, they shoot out the mails to the manufacturers and they'll create one more vertical under the sales telling that okay, these products and because they are in demand. So this is predictive demand, very similar to that even in the manufacturing industry, like what is there and what is the sense of understanding. Say example, in the coffee machines, what is that flavor that is running, and to the thing which mission they are using more, also which mission they are in. So there what was been filled. So if same company is buying from two different regions the coffee, or they have coffee plants into one maybe in Coorg, another one Chikmagalur. So one may be of high demand, another one may be of low demand. So all this they are predicting. So the predictive is something very intelligent thing that has to build, and this takes at least 10 to 15 years for all the things that are existing to go on, and till then lot of job opportunities. Then predictive maintenance, data fed sensors identifying possible failures in the operation of machinery before it becomes a breakdown. By identifying breakdowns in patterns, the system sends an alert to the equipment so that it can react in time. Then these are just some of the benefits of big data analysis in production, but there are many more. Improved security, load optimization, supply chain management, non-conformity analysis, and list goes on. So let us understand that how this big data provides information. So it provides valuable information on key elements such as market or business directions, identifying which ones will potentially generate the highest profits. So this is what I was giving you the example. It's how do you predict this? So for that, you need to collect the data first. Collecting the data, if you have the data, you need not be a programming engineer or a artificial intelligence engineer today to make money. You collect the data, you put some people, invest on them, collect the data, keep the data with you, and put it in a small way. This data is available on social media, and people will start approaching you. You will not even understand why they needed that. Also, some other company which it was not there in your mind, they will be asking the data. So this is how the data is generated. But otherwise, companies who are doing prediction much before for their benefits, they are hiring a separate department. They're putting logistics in place and people in place, and they are getting the data built. It's a fundamental for making strategic decisions such as expansion and development plans or financial analysis. It's therefore become an indispensable source of industrial sector in two main aspects. One is hyper-connected context. Second is smart factories. What is this hyper-connected context? A very high and growing percentage of business activities go through or related to internet. This increase the amount of data recorded and stored by companies, both online and offline, to exponential levels. Next, so while industrial companies years ago lived exclusively in limited geographical areas, today, they are establishing their franchises in other parts of the states, in their own country, or otherwise they are going global. So they are either getting tied up with some other country to get it launched with some other, say example, Mahindra launches so many other products apart from their own manufacturing automotives. So these are all the benefits. Okay, so already they have the marketing strength there. So tie up with them, try seeing whether I can go and establish my vehicle sales also in the other countries. So these things are physical barriers. Today it's just that they are breaking, and they want then. So this is hyper connected context. Here, information of power, implementation of big data in to evolve strategies, all these are a process of hyper-connected context. So my interest is smart factories. So it took so much time to get into smart factories, but I know that I've given you insufficient examples of smart factory, how it works. So, but otherwise I'll concentrate on smart factories, how the, these keywords of digitalization, big data, cloud computing, etc., works in a smart factory, which otherwise is an improvement from a programmable automation, which was called as Industry 3.0 to Industry 4.0. Here, smart factories, big data helps to integrate previously isolated systems so that companies can obtain the complete visualization of manufacturing process. So here automates data collection analysis. So a lot of sensor-based technology are needed here for everything. In that video, what I showed, so a lot of things will come, like movement of conveyor, the movement of robots picking and placing, stacking, welding, what is the weld current. So many things has to be made it more perfection, so that there won't be any error after manufacture. When it has been produced only, we need to correct it. That is where the smart factories will evolve. That goal only of smart factories will evolve. So here the better understanding of status of each system, both together and separately, needs to be worked out. So applicability. So here, when we are talking about big data lines, so it is enterprise resource planning, supplier relation management systems, product lifecycle management systems. I have told what is product lifecycle. Enterprise resource, SAP is one thing, a lot of jobs today otherwise, wherein that remotely, we say example, TCS, Infosys, and Wipro do a lot of this enterprise resource planning. So what exactly they do is that they'll put a team of in a manufacturing firm. Say example, if you take a petroleum product, say MRPL, like Mangalore Refineries Limited, when in that they'll depute few people online. So there they collect all the data, but otherwise this data has been upgraded somewhere in a online mode in one of the call centers, or what you call it as otherwise a call center or something, wherein the support system, wherein that they are monitoring continuously or monitoring the manufacturing firm. So something is popping up telling that some defective is there, some parts are need to be ordered, they are going low, they are not getting any inventory in time. So all these things will be addressed and they done. So enterprise resource planning integrates raw material handling, processing it, assembling it, warehouse, supply, and complaints, including complaints. And so after sales, if there are complaints, even that they will take, including the insurance people queries also they will answer. Next is supplier relationship management systems. Then product life cycle management. I gave the example that product that has been made generally in mechanical wise, we plan for 20 years, 5 years like that. During that living time, we will maintain the health, we will call it as health monitoring. So something is going wrong, why it's going wrong, rectification, next model, we need to enhance the efficiency and we need to implement and see to that the product serves that duration. So that is the main objective. Here, product lifecycle management are two ways when I am talking about automotive industry. Say example, a printer or a car, I'll take as the example. Say I have, there is a HP printer on my desk wherein that it's a laser high-end. So all my staff take print in this. Okay, it's the same printer if you have at home and if you are not taking sufficient prints, so still it should serve either case. So very similar to this example is that if a taxi person buys the vehicle, 1 lakh kilometers he will cover within a year. But whereas if I have bought and I have taken 7 years to complete that 1 lakh, so it depends on how much I drive. But maintenance is something different. So what is that I need to make? Whether you use it or not, the maintenance has to be done. So that cycle need to be established, and when it has to be scrapped, that also needs to be worked out, and that is what is product life cycle management and more environmental responsible systems. Here today we are talking about environmental systems when we are talking about material and electronics, semiconductors, all that. So one small way I'll put, see anything that we make today, it is the challenge is that like no on your refrigerators and all you have seen, there is a print, okay, energy. So how much power consumption efficiency they'll put star, 5 star or 10 stars they'll have. So 5 star or 3 star, 4 star, what is your energy rating for that equipment, you know. Very similar to that in an automobile and manufacturing industry, there is a green print, what we call it as, where like know how many parts in your manufactured product can be recycled. So based on that, approval will be given to manufacturer. Not all countries permit the same product to be used. Some parts cannot be recycled. Countries are stringent. They will allow them. So the big data information is analyzed in 3 layers: the past, present, and future. This also you need to keep in mind, so that you can do real-time analytics in a best possible, reasonable way, so that which includes reasoning on casualties and projections in future. So this data-based integrated supply chain management approach, while increasing value and efficiency in manufacturing, helps reduce inventory and capital requirements in the medium to long term. So what is this inventory? Again, I'll give you a small example, okay, so that all of you understand that what is this inventory, what I am talking about, because everybody want to get into this newer business of industry 4.0, and all the course material what we are developing needs to be relooked at. So again, all of you, to make you all understand what is this inventory I'm talking about. Say example, Tata vehicles will come out with a new vehicle, okay? So then they will come out with Harrier as the new vehicle. So before the launch of Harrier vehicle, if they want to make any Harrier vehicle, and they want to launch, one example only I'm taking, like there's so many manufacturers, so many things that will be launched, but one vehicle I'm taking. So it is not only that, if they are launching, say, on the launch day, they are putting 1,000 vehicles on the road, okay? See, there are at least 5 lakh components that have gone in making that vehicle, okay? All these 5 lakh items, so, and it is distributed, okay? All over India, they are launching. So it is a distributed way wherein that the vehicles are being booked remotely somewhere, and manufacturing plant is there, say example in Pune, okay? So now all these service centers need to be at least like few places. If you take Bangalore, at least there are say 40 service centers of Tata. Then simply I'm taking one number. So at least 4 to 5 service centers, few components need to be kept ready. of what otherwise they will launch the vehicle. They need to have the inventory made more. That means 1,000 vehicles means at least another 400 parts of every type need to be made, and it will be stacked all over India, so that because after you hand over the vehicle to the customer the first time, like driving, the first day itself you will go crash. So 10 components are needed to be replaced. So the inventory need to be made ready. So this inventory, if I can, and there may be failures also after usage and the improper usage or something. So then I want a replacement there. If this inventory, so you need to understand it as a company, though I charge for it, but otherwise before I need to invest and keep them ready, because after sales, if there's something gone wrong, 3 days maximum, the customer will wait. Even if he has done an accident, he will wait for not more than a week. He will demand that I want the vehicle back. So before that, it has to be refitted and need to be handed over. And this is what is how is this integrated supply chain works and how we can minimize. This is where I was telling you of manufacturing and keeping, instead of having all the manufacturing in one segment, distribute them. Small manufacturing centers you have remotely at places where there is high demand for your product, and something goes wrong, address it within. And how much time? The time is a challenge. That's what even Sunita ma'am was telling. Time is a challenge. Most of you are asking what is that time, and that is where it has to be minimized. So what would be Industry 4.0 without big data? Modern factories are becoming increasingly complex and interconnected. So here, how automation can be addressed. Next is modern computer systems. They are also being enhanced. They're today this is just that the amount of storage of data in remote laptops, etc. A lot of data can be stored and it can be processed. So next important thing, how complex information networks can be generated with a lot of safety. Then the one is predictive maintenance, and finally it is the intelligent technology that it can support. So how data analytics will transform big industries? So by these two methods, predictive data analytics, driving force behind the modern marketing. Use predictive analysis can help companies to find better leads, better align sales and marketing, and set up marketing automation, understand current customers. That is what is very much. So how is this big data stored? So it is just that I've just put Hadoop distributed file system. Some examples I've put. So it stores information in clusters that are made up of smaller blocks. These blocks are stored in on-site physical storage systems such as internal disk. Next, what is a smart factory here? Here, when we are defining, it's to describe the application of different combination of modern technologies to create a hyper-flexible, self-adapting manufacturing capability. Here, smart factory initiates might also be referred as digital factory or intelligent factory. So, and what are the characteristics that we need to look at? So, smart factory refers to factory that integrates physical production process and operations with digital technology, smart computing, artificial intelligence, and big data. It offers promising effects of production and manufacturing, such as improved productivity, reduce cost, reduce downtime, and minimize waste. What makes it smart? Okay, a combination of interconnectivity and tools known as cyber physical system is what it makes smart. They allow tasks to carry out with more efficiently by collecting and analyzing data. I'll just give you an example here. So all these days, automotive manufacturer means very few were there. Okay, brands means, but gone are those days. So Google is making their vehicle, and you have seen Tesla coming out with a lot of manufacturing expertise. They are launching their two-wheeler in India, and four-wheeler also they are planning in Karnataka itself, and they are highlighting that they want to have a manufacturing unit. And so Mahindra, a long time back, they took Reva. Reva was the first electric vehicle launched. Again, credit goes to Bangalore. We are the one who gave the electrical vehicle for the market in India, self-made. So this Reva, when it was been taken over by Mahindra, today what is the health monitoring system they are talking, and what is the sensor system they are talking? And just highlight for you, it is just that they want to put so many sensors that on road, if you are driving, and if they will be predicting something you are not driving well, or some battery is not functioning properly, some controls, or your AC is not working properly. remotely. It's already connected. They want to connect this system with their hub and with their master computer. There it will analyze. There'll be expert who will go through. And directly he will send a message to the owner with the register mobile, telling that something is going wrong in this vehicle. So that extent, tomorrow it is all connected. That is where the technology will lead. So you are part and parcel of the system, wherein that they are monitoring you, and the challenges are there. So why somebody should monitor why somebody should follow me, whether I am in Mangalore, Goa, or Bangalore, why somebody should track. So these are the challenges which the government has to give the permission, but otherwise technology wise, that is what they are building. So it is just that remotely you get a message telling that something is not working whenever the vehicle is connected to the internet. So whenever it gets connected to the internet, it sends a message. So why are smart factories important? So the smart factory allows the minimization of production process times as well as cost. It will be able to adapt, optimize the process. In addition to storing and analyzing the data in real time. So this is how the smart factory looks. There'll be cloud computing. There'll be internet of consumers. So you are the customer. You are at home, but there are so many things are being connected. That is the physical world and the cyber world are interconnected. Physical world is the production process, all that goes in manufacturing, which is a expensive stuff, which is being overlapped by cyber world by using big data and internet of things. Already industry 3.0, it was a programmable automation. It was completely automated. It's not that people are there, but today they are attaching a human interface through cyber world and cloud computing, and they are, why all this? Just to give the customer much more better experience of what it was earlier and what it will be in future. Here the smart factory equipment is a concept of deriving industrial internet of things which is fully automated and intelligent. Here logistic chains are being controlled with experts without human intervention. So coming to the cloud computing in smart factories, uses internet connections to store software and information used in business. Both of them today, manufacturing and business. That means taking the order, seeing what is the customer needs, and again augmenting it virtually, and then placing effective way of manufacturing it is a big challenge under Industry 4.0. So here the technology has increasing use in manufacturing, business operation, and production. Both are being integrated. In 2017, 25% of finished product inputs were made using some type of digital technology such as cloud computing, but otherwise it's growing pretty faster. Now, what is this smart grid in smart factories? So it is all about what is the electricity that has been used, how we can minimize. This again is a benchmark. So all machine manufacturers, machine tool manufacturers are working on how do I reduce with use of minimum amount of electrical energy, how we can convert the products into components. So they are evolving alternative. As you have seen that government is also supporting a lot of wind energy and solar energy today, and many states have taken the initiative. Even in universities and factories, they are implementing either solar energy, and they are just finding the alternate way of getting the power. So some of the examples of cloud computing, so software as a service include Dropbox, Salesforce, Cisco WebEx, and these are some of the things that are already available and which are being utilized. So what are the principles of cloud computing? So I'll just put it in a best, easiest way, because for mechanical engineers, we need to tell them that what is the simplest way of understanding this cloud computing. So I've tried putting it in a simplest format. So there is a data, okay? Raw data will be something like in the first picture. So first thing is that you sort it out, then arrange it neatly in size wise or something. Then make a very good presentation of what is available, the data, then see that how it can be applied. That is the application aspect. So say example, in this picture, it's a house that has been built, which has a story. How you collected the data and how you utilized it is what makes a smart factory. And how is this data stored? It is stored in cloud. So how you can retrieve it, how you can process it, how you can make it a useful information, how you can present it to the customer, and all this is money. All this is money. That's what I told. Data itself is a money. There are so many other people who will be interested if you have the data. And finally, if you are a story builder only, you can make something out of it. So that thing like that, say maybe airbag deployment gadget, or it may be a a diabetic checking instrument, or anything wearable. It can be a wearable, or it may go to a equipment. Say example, swimming pool. What is the quality of water? So if you can develop a gadget, it's a technology. So through internet, today I'll check what is the quality of water. If it has rained last night, I can check, and then only I'll enter into water. So very similar to that, drinking water or anything today, if you can connect and if you can have a measuring, quality control, etc., nothing, that is what they are trying to establish even in with the companies. So the 6 principles include enablement, cost benefit, enterprise risk, capability, accountability, and trust under cloud computing. So what is cyber physical systems? Are engineered systems that are built from and depend upon the seamless integration of computational algorithms and physical components. One example of CPS is intelligent manufacturing, where the machine can perform many work processes by communicating with the components. That what is the feel of the component is also been felt. So it may be a food processing unit, wherein that you are today there are things which are I don't know how many of you have seen how the dairy work today, milk dairy works today. Even at the remote place where the person who is collecting milk from the villagers, from the farmers, today he has been equipped with a IoT instrument. He has a mission. He knows that what is the fat content, everything. Just that he needs to give a sample of that milk to the mission and the code of that person. So automatically is things are updated according to the milk quality only. You will be paid. It is not everybody gets same money like earlier times. So today it is based on the sample testing. The machine will decide, and the copy will go to the dairy person also, and the money aspect also updated once in a month. It like no, the complete summation of that money is been credited, and so now people are not diluting the milk. Instead of that, they are feeding the cows with better things so that it can give a better quality milk. So that is what the power of this cyber physical system. That is the power of this cyber physical systems. You have not seen that system nearby any dairy, like no, any village you can attend where they run a dairy, and every other farmer today who's running that dairy collection of milk, he has that equipment. So on internet also it's available, YouTube also it's available. But otherwise, my suggestion, anytime you get an opportunity, you can visit. Morning or afternoon, evening, they will be collecting the milk. At that time, it's a better time. So what is CPS in IoT? So cyber physical systems and Internet of Things are both complex platforms that share a common goal of increasing technology reliability, expanding advancement opportunities, and exposing areas of untapped potential. And this is how it looks. Okay, cyber physical system. So sensor spoof. So how the packet communication, all that happens in the middle attack, resource blocking, and authentication, how it happens when you want to run the actuator for automatically taking the control of that. So this is where is the challenge. So one example I want to give you. So when we are talking about autonomous cars in future, okay, when so many companies, as I told you, Google and all are working on autonomous thing, like no, not everybody say example, Bosch never made their car, okay, but otherwise if you open any car, any brand, anywhere all over the globe, it will have 30% of the components from Bosch only. Well, even TCS does the same, okay. And, so many companies, there's so like that. One of the company was entering into this segment of sensors for Industry 4.0 updation and like no, for autonomous vehicles, especially wherein that there won't be driverless vehicles is something which has already been proved. Like Amazon has its vehicles for delivery purpose, etc. So who is a master here who is making this sensor and actuator is Sony company, which otherwise is known for your cameras, entertainment systems like audio system, televisions, etc. Today they have entered into this segment, sensor and actuator for Industry 4.0, because already they have the brand name and they want to give, because tomorrow somebody can hack any system is not that they will hack the software or anything. They can hack a sensor reading or an actuator movement. So that is where again lot of security system needs to be built, because when I'm handling I showed you the manufacturing form, how it is working. Okay, all robots, they are all very expensive, millions of dollars invested. Okay, somebody can hack, and if they can get control one robot also, it's highly dangerous. So if they recode something with relevant to sensor or actuator, so that is where the cyber physical systems and storage and computing comes a very big challenge for the outside world. So otherwise, this is what is Industry 4.0. There is a cyber physical system, there's a mission tool, industrial computer and network analyzer, cloud storage, and real-time visualization, which is all controlled by Internet of Things. So for already existing blue system, these two new systems have been added, that is the cyber physical system and the Internet of Things, which are in green color. So this is how, otherwise industrial computer network already was there in industry, because a lot of programming methods only we used to run the automation. So otherwise, the way the cyber works is in this picture. Reconcile and understand what is required. That can be done only by sensing, and then value creation. So I have shown you how the data can be collected, how it can be segregated, presented, and making business out of it. So analyze and predict, optimize and plan and control is value creation. This is where a lot of new enterprises are coming in as startups. A lot of people, otherwise OEMs, etc., original equipment manufacturers and all, they are funding the other organizations to make a successful business. So smart factory is futuristic. It can produce and deliver productivity much beyond our expectations. They're already with us today. Operational, they can use RFID or near frequency contact is something new. For example, in a shampoo manufacturing, if they have varieties and they operate separate lines for production of each in today's factory, in smart factory, the single line is equipped with intelligence and can produce and fill different shampoo requirements based on demand. So this is what is in a simple way the smart factory. So earlier, if it is 50 ml or 100 ml or 500 ml and color based or variety based, so they used to run different lines. But today it's just that they want to equip everything into one machine. So based on the demand, based on the person's requirement, just like a vending machine, a coffee vending machine, wherein that there are different flavors. You press what you want, it will give, and that is what they want to do in the futuristic factory. So this is where investments are going on. So some of the things that they want to call it as smart things under smart factory is smart grid, smart building, where somebody told that, okay, it's on smart building also. So smart building and cities, which Modi also tried making it, and it will happen. It will happen. It will take time because infrastructure requirement is huge. It is not so easy. Smart services, smart workplace and environment, smart mobility and traffic, smart logistics is where people are looking at, and smart home. Finally, who will give all that is the manufacturing industry. So that itself need to be first equipped in order to make all this possible. So is that smart things existing today, and is it that Industry 4.0? What is that the upgradation? I'll just give you an example. Yes, smart things were existing. Say if you talk about NASA or ISRO, etc., wherein that they used to launch these satellites, or if they did their Mars mission, etc., sending people and mission to the other planets. Yes, that is the distributed control system what they developed. Okay, so sitting at some place, sensors were being placed, and they've been continuously recording what was happening, and any malfunction of anything, they used to take control. Yes, it was existing. They were very successful, but it was very expensive. But today, why all these things are becoming smart is that affordability, that is mass production of electronic things, the chips and MEMS devices, and integration of this with the already existing systems is what is making everything smart. So this is how the entire smart factory will be functional. So instead of robot, you can see here we use a word cobot, wherein that there is a human interface also along with the robots. There's computer vision, mission analytics, IoT sensors for supply chain management, smart packaging, unmanned track, unmanned aerial vehicles, wherein that a lot of things will be delivered within and outside just-in-time methods. Industrial augmented reality. So next, the other side. So what is that? Predictive machine analytics, industrial augmented reality, IoT sensors for supply chain management. These are two different pictures. Okay? So I have not named them, but otherwise they are two different pictures. Modular equipment. Modular means that like no, what is needed for that place only it will be put. Other extras will be removed. So they'll make it modules wherein that what is needed only it will be functional because of less power consumption and less space and flexible automation. This comes computer vision and unmanned tracks. So future is unmanned trucks. Already it's there. In some of the countries I've read that there are unmanned trucks for delivery today. So what are all the things that this smart factory economy talks about? So it has been bifurcated into three different levels. One is remote control, central computer, smart mission, intelligent users, data exchange, optimizations, and all this. So on the other side, it is smart services, condition monitoring, predictive maintenance, online services, remote maintenance, virtual missions. All these two parts, like finally helping the smart production. So here, one of the very important thing for the economy is that traceability. So traceability is the very important thing. Who has taken the order? Who is because you are fighting against the time, and it is the customer who is not having the patience to wait. So two systems which comes very handy in this smart factory in action is one is enterprise resource planning, another one is manufacturing execution system, that is pronounced as MES. Here the entire system is controlled by your ERP system, production based on orders based on supply chain requirements. So MES fulfills this, that is manufacturing execution. I skipped two things because it was all about that shampoo manufacturing, how that R1, R2, R3 can be mixed and obtained. Okay, that was the example to explain for a mechanical thing. So I just skipped it because I will give you a different examples for you. Say general. So sorry. J's Brilliant Factory. Here, G has invested over 2 million in a flexible new Brilliant Factory. So here, that will produce diverse product from jet engine parts to locomotive components for 4 different GE business, all around one roof for the first time. So earlier they used to just do what is required for one system is one exclusive systems they used to make, but now they are making flexible systems, wherein that they are calling it as Brilliant Factory. It's the same machinery and same people being used for producing 4 different products. So here they will also assemble wind turbines and build water treatment units for oil and gas and agricultural industry. So the plant will allow us to quickly adjust production as demand comes in using the same people and space. So this particular factory segment is in technical words is known as multimodal factory. Coming to Airbus, smart tools and smart apps, what they are working on. So Airbus are using a rapid prototype approach to incrementally develop new technology from initial proof of concept to real application. Airbus views the automation of assembly line process as one of the main areas of change in the factory of future. Here, what is that they are looking at is the result in real-time decision making based on local and distributed intelligence in the network. The application presents real-world example of integrated in manufacturing. It's very similar to that Siemens Hamburg electronics plant, where it is manufacturing schematic programmable logic controllers from 1989 was recently won Industry 4.0, wherein that they are optimized to digital twin technology. So I don't know how many of you have studied about twin technology. Kindly go through with that. It is also picking up. Twin technology is also building rapidly in the market. So there are a lot of engineers who are required in twin technology. We can develop students on that. For example, if a robot is soldering an assembly onto a PCB, our system first check whether the parts work properly before it is taken any further. In our factories, we check each process step and each component for quality and use intelligent algorithm to do so. The result is process stability combined with high quality. In many factories, however, quality checking happens only at the end of the manufacturing process. Say, example, you are making an integrated board. So every part will be previously only it will be checked for the quality and efficiency. And after that only it will be assembled. It will not be. So that is what is the upgradation today. So by doing so at the end, it will not get rejected. After being assembled, it will not get rejected. So by doing so, it saves a lot of waste and time. So, this is how the new firm looks with all these sensors incorporated. So next is something middleware, which plays a crucial role in IoT. So with many objects connected in IoT solutions, here the environment in which they are placed becomes smarter. And a software called middleware plays a key role since it is responsible for most of the intelligence in IoT. So there are a lot of softwares and open source available. People can train students on middleware softwares. So what is that? It is responsible for the most intelligence in IoT, integrating data from devices, allowing them to communicate and make decisions based on collected data. So what is middleware with the example? Middleware is a software which lies between the operating system and the applications running on it. So common middleware example include middleware application server middleware, message-oriented middleware, web middleware, and transaction processing monitors. These are the various types of middlewares that are available. So here the types of middleware include database middleware, application, message-oriented, and how many types of middleware are there? So at least 14 specific types of middleware software are already there solving problems. Some of the platform that are used are application programming interface API, as message-oriented middleware, object middleware, remote procedure call, database transaction protocols enabled, and centric middleware. This is all the middleware architecture. So when I'm talking about middleware architecture, this is how the entire schematic is done. So there are microsensors, analytics, data visualization. So everything is stored in different layers here. And people were asking security. Okay, so how the security is been provided for a real-time application to the cyber overlapping is by these steps, these middleware steps. So what does it does? The first thing is the microsensors layer, then analytics, data visualization, integration, processing, transaction correlation, and end node management and connectivity of sensors and actuators. This is how it is overlaid otherwise in the real time. So 8 components of end-to-end IoT middleware stepwise is connectivity, end node management, data processing, data integration, data visualization, analytics, front end, and finally it is the security. So what is that? And the middle people, if they are involved also, they cannot take out the data. So encrypted and kept it in a format. So popular commercial IoT middleware platforms include Oracle's Fusion and IBM Bluemix. Some of the other things also have examples here. Like Kai is the multi-purpose middleware platform for the Internet of that allows building complete end-to-end IoT solutions, connected applications, smart products. So this one majorly it has been used. So what does it support? It supports connectivity, scalability, administration, and data streaming analysis for potentially millions of nodes. Otherwise, pictorially, a typical uh, operation technology manufacturing network looks like this today after implementing the middleware and IoT into the thing. So there is a PLC, there's a human interface mission where you can code and you can put the things. Then industrial PC, power monitor, PC control, PLC. So otherwise earlier it was just program the programmable logic controller. As I told you, it's a lot of things were programmable only. And it may be a CNC machine which has a PLC or a microcontroller inside. And that is how it was done. But today we integrate these things also, the middleware also, wherein that it serves better between the sensor to actuator what we are doing. So this is how the typical operation technology manufacturing network looks at. So coming to the security and manufacturing, security is the major issue in industrial IoT when compared to the IoT alone, since rarely firewalls and intrusion detection done in IoT. It is not required. We need to eliminate that step. You cannot keep on scanning, because you have seen that even sometimes when the scanner is put on our laptops or desktops, so it takes a lot of time. So how many times you will do and what is the frequency of doing it? You need to eliminate that. And for stage itself, there should be a lot of safety. Here, Industry 4.0 environment, operation technology networks are not IT networks. This you need to keep in mind. Operational technology networks are not information technology. They are they have a different topology, components, protocols, and purposes. Say example, I'll just give you, when you board a lift in the apartment or a building or institution, it's just the protocols or PLC, programmable logic controller is being, so it has a systematic way of working. If 2 or 3 lifts are there in the same floor, if you press which is the nearest one, if he has pressed to go up or go down, so a lot of logics you have taken, like step-by-step procedure you have programmed, and accordingly only it will work. But tomorrow your algorithm or intelligence should help what is existing and give safety much beyond this. Not that you can use something very different, like just information like when a business protocol comes into picture or something, and you cannot. So finally, customer should be satisfied. That's what it is. So by adding all these things, it becomes expensive, and also you need to see to that it's a beneficial for the customer. So IT is deemed to be all the systems, application, people, and networks required to manage information technology. So industry control systems is all the control systems, that is PLCs, desktop management interface, which is otherwise popularly known as DMI, people and networks responsible for operational and production tasks. Windows Server is rarely deployed in industrial OT environments since it does not satisfy OT demand for availability. So this and just things which are giving the hints that rebooting of server is not something OT would consider acceptable. It cannot, as I told you, it is not acceptable only. It cannot go wrong. Well, there are people, there are mission, there are products which are there on the mission. Say in a engine block, say there is a cast iron block which you have given. So it has been converting that into an engine block. So somewhere it cannot reboot. It cannot reboot because it will lose all the information. Where it has stopped also it will lose. Then that, it may damage the mission itself or the tool or the one product itself, which is there on the bed. So all these are not part and parcel of IT, which adds on to the OT. Rejection of Ethernet and Windows in industrial OT networks, ID another major difference between OT and IT. And OT systems are dedicated and expensive. This also very, very. So next comes PLCs and DCS. So programmable logic controllers, since you are all electronics, I'm not getting into too much of that. But otherwise, what is a distributed control system? And what is that it's doing? What is that we need to do is we need to come out with human machine interface, which are used in mission to mission, which are non-IT protocols. This is what is to be developed by using your PLC and DCS systems. What is that we need to get is that human machine interface, which are used in mission to mission. So mission to mission, they need to work either like autonomous vehicles, which are there on the vehicles. So the manufacturer, then what is that autonomous vehicle technology? I'll just brief you so that you'll understand this in an easier way. What is that I'm talking about? Mission to mission here, it may be, there may be a turning machine, there may be a milling machine, there may be a robot. All three are three different missions. Then they are working together and along with the human one. So earlier, human, if he goes in between, it will halt. The procedure is that there will be a sensor at the top, it will halt. But today, along with the human, it will continue and it will not harm the human being. So otherwise, an autonomous mode, I'll just give you. There may be a Maruti Suzuki vehicle, there may be a Hyundai vehicle, there may be a Tata vehicle. So autonomous vehicle, they're all coming, they're all interconnected through the satellite, through the networking protocols. So what speed each one of them are coming, they'll not clash. They'll just see to that without harming each other, they will move. That is what is required. So here in Industry 3.0, it was all programmable thing. So human was not there inside, but in this, human also becomes interface and missions also, they also need to interact along with the human. And this is what it is. Very few companies like Siemens, Rockwell, ABB are automation vendors. So these are this equipment, hardware and all we can buy from these people, including General Electric. If we compare OT technology topology with IT topology, it is just that there's a small major functional difference is that how we use the protocols and standards. So how do we secure? So if you see, this is what is the distributed control system. So it will be a master control wherein that other things are being integrated through sensors. And for the signals, we'll put the actuators on or off. Whether you want to do the rectification, etc., actuators come into picture. Here figure shows bus structure of a network and each area of production or process defined without any of the data segregation. Here routers or firewalls common in a IT topology. Here the common IT practice is to segregate each area, preventing unauthorized or irrelevant trafficking from entering a specific area or zone. This is what I told you. So it overlapping is not at all allowed. There will be major disaster if something like that happens. So this is altogether a technology wherein a lot of people, a lot of intelligence will go on making this. And it takes, as I told you, 1 decade to 1.5 decade, 15 years at least is required for completely getting to the every other industry that are operating today. So security issues you can find as network level, system level, and ICCRT monitors the attack to someone systems. So otherwise, how it is overlapped: external networks, corporate networks, enterprise network, process information network, and process control. They're all different layers, different people, different operators. So combinedly, they are working. Okay, so not that if General Motors is making a vehicle, they have outsourced a lot of things for other corporate people and other enterprises also. They are all overlapped. Everybody are working together. A lot of security is being taken into consideration, and together they put this into an act between the mission and the control system. So with this, I'll conclude my presentation. Thank you very much.
Thank you, sir. It was a very nice, very good, very informative presentations. So all of the participants have already reacted. So any questions from the participant side? Any questions? So I think they have understood fully. So there is no questions.
Or it was too many things to understand also maybe.
But
I don't
very,
know how to take it, but otherwise.
Yes, it was very nice session, sir, actually. So you can see in the chat box also. So they are all putting. So one question they have asked: which industry sectors are leading in adoption of IoT in India, sir?
Ma'am, according to the latest this thing, there are two divisions which are doing. I will not take the industry, because all of them need to understand. So gone are those days wherein that say if you take some of the examples I'll take, because your college is just in very close to the electronic city on the same road. If I am talking about, there are various companies which are manufacturing industries. So if I'm talking about 4 or 5 companies here, say there is a Mini Group which are there into automotive segment also, and aerospace segment also. So they like very similar to that. If you take Bamsandra area and other areas here next to you, and I just want people like faculty also to visit these industries. So they are being given orders, okay, and similar somewhere remotely from Germany, they'll get the orders to manufacture here and send. Even the raw material has been sent from them. CAD drawings have been sent, machinery selection, everything that has happened from them. It is just that they need to manufacture here. And what is that they lack there is the people, infrastructure, and there are a lot of other challenges there, the climatic conditions and all. But otherwise, from here directly, they will send it to other countries, Asian countries only. It may be for assembly purpose or spares. Why I'm telling you this is that every other industry they are trying to bring under Industry 4.0. So people are understanding which company will get in. So it is, say, example, today, if it is Airbus company, so Airbus company in the last 3 years, even with COVID conditions, they have given more than 4,000 companies just within Bangalore for a lot of manufacturing. So earlier to now in Industry 3.0, they didn't add the control of controlling what was being manufactured. But today it is just that by sensors and visual systems, they are able to capture what is happening. Everything that's happening on the mission, it's just that you are manufacturing your supply chain has been fixed by them. It is your inspection techniques, everything. So here almost all industries are upgrading into this. So one information I want to give you is that all the industries that were there earlier, they have been, take it, any industry that is operating next to you today. You may talk about SS Spring, or you may talk about SKF bearing. And so as and when they are getting the thing, where it will go, everything has been tracked. They have been coded very well. They'll track that product, so nobody can intrude into their system. And where it has been packed and where it has been received and where it is assembled, everything is tracked today. So that's what I want to say in this regard.
Yes, sir. So the next they have asked, how can we save environment from industrial revolution, the way data increases and heat generated by the data centers? So the environmental friendly question.
Yes, very good question. So this is where the manufacturing industry is not only with the heat generation, otherwise also, business wise also. What all these days was happening is that whether the customer buys or not, the people used to manufacture a lot of things and keep, okay, which used to pollute a lot the environment. But today, with integration of industrial IoT into the OT, is not only just manufacturing, it is even the business. So as I told you, so unless they have the order, they will not manufacture. So then and there itself, 50% of the manufacturing comes down in terms of inventory. And with the already it's evolving. 3D printing is evolving, and it will lead to a much more bigger thing, because what is there and what is not there, I'll just tell you in 3D printing. See, till metal 3D printing, it is all available. It is additive manufacturing, layer by layer manufacturing, and components are made, tested, and it has gone into assembly also. The parts are working within the printers or household appliances, or what you talk about, your refrigerators or your microwave ovens, or if you are talking about your chimneys and televisions, etc. So everywhere the parts which are being manufactured are already evolved and they are getting into it. So these products, they need not create the spares, etc. If there is an order, they'll manufacture, they keep, they will deliver. So one of the basic thing they are looking at 3-day manufacturing. That is what somebody told, ma'am told, Sunita ma'am told that manufacturing, yes, they want to reduce the time. So what is next is that it may happen, and all of us will witness it. It's working towards that pretty fast. 3-day wherein that customer orders, next day production, next day, third day, it's just that it will arrive. And manufacturing, they are streamlining the entire things with association and working together. Gone are those days. OEMs will keep, original equipment manufacturer will keep things for themselves, and they will do things for themselves. They will depend on other people. There will be a lot of agile manufacturing, wherein that customer to product, they are directly linked. What you want in that only will be added, and it will be given. And you can improvise also. You want something extra also, then they may take little bit more, they'll redesign it and look into it, and they manufacture and give. That's where it is leading to.
Okay, sir. Thank you very much for this wonderful session. I thank you, sir. Sir, kindly send the PPTs to my mail ID, sir. Most of the participants have asked, so we will be sharing with them. So kindly send the PPTs, presentation of yours, sir.
Sure. I'll do.
Okay, sir.
And I want to thank
you.
Professor Prasanna Kumar.
Prasanna Kumar, yes, sir. Yes, sir. So through him only we got your contact. So thank you very much, sir.
Yourself. Thank you, and thank you for all the participants and all the institutions and AICTE also. And thank you very much for giving me this opportunity. Thank you.
Thank you, sir. So dear participants, so for the afternoon hands-on session, I have sent the software downloading, which software has to be downloaded. I had sent through the mail. So kindly check your mail IDs. So for the afternoon session, so please download the softwares which are, the link has been sent to your mail IDs. So, and the instruction manual also it has been sent. So kindly start downloading the software. If any problem is there, so we will look into the at 2 o'clock for the next session. So they'll be assisting us, the resource persons, they'll be assisting us to download the software and to execute the hands-on session. So thank you. Now the lunch break. So we will meet up again at 2 o'clock. Thank you, everyone. And the Microsoft Teams link will be same only. So you can join through the same link only. Thank you.